Hello, and good morning. It's good to be here. I see a few familiar faces here today. The most recent BSD conference that I was at was in 2019. So it's good to see those of you that I've not seen in that 6 years and to connect with those I've worked with in that time and haven't had a chance to meet face to face. I'm the speaker before lunch, so I'll keep it short so that your lunch isn't cut short. I think that I have around 30 minutes of content, so we should be good to go. For those who don't know me, my name is Rick Miller, and I'm a Unix systems engineer at Verisign. I've worked there for about 20 years. Verisign's a DNS root server operator and a domain registry for the common net top-level domains. I've been working with FreeBSD now for about 15 years in my role at Verisign, where I specify and implement FreeBSD OS standards within the global DNS infrastructure. What that means is I manage the FreeBSD base OS and ports build pipelines, base and ports software lifecycles for FreeBSD in the DNS, and the baseline OS and application configurations in alignment with CIS, NIST, and other security standards. I also support diverse OS installations for DNS resolution and domain registry systems using both Linux and BSD operating systems. I'm presenting today OS diversity and FreeBSD in the field. I won't be able to cover specific details about our use case, but I will be able to describe what OS diversity is, why it is important in practice. I'll talk about a few examples where OS diversity is important in practice, and I'll identify a couple of organizations that use an OS diverse strategy. Finally, we'll touch on reasons why an organization might choose FreeBSD as a diverse OS platform. This talk in general tells Verisign's story from evaluation, adoption, and deployment of FreeBSD in Verisign infrastructure. Though some of the details may differ, it's important to us that the security and resilience of the DNS and ComNet registries is upheld. So we deploy an alternate OS that is a tool used to deliver on our core mission. We don't have cycles to be focused on the OS except where it concerns our core mission, which is to enable secure and reliable communications on the internet. We've developed relationships in the FreeBSD community which allows us to deliver on that mission. First, allow me to acknowledge and thank the FreeBSD Foundation for inviting me to give this presentation and the community for its interest. So, what is OS diversity? OS diversity is the deployment of multiple server operating systems in networked and distributed systems. It is a contrasting notion to monocultures where a single operating system is deployed. OS diversity enables operators to ensure systems maintain proper behavior in attack and intrusion scenarios by adjusting or realigning system resources when one OS is impacted or targeted. It is appropriate in systems with extensive deployment and testing protocols where same-day patching strategies are not available. And the notion of OS delivery or OS diversity may contribute where organizations operate critical systems that must be resilient to zero-day events. Consider things like the internet infrastructure and the DNS, the domain name system. Also consider cases like municipal emergency services like fire and rescue. Also think about transportation collision avoidance systems, where system failures could result in loss of life. There are also economic and geopolitical impacts. The internet is the digital battlefield where the nation-state economies, politics, elections, and commerce may be vulnerable to zero-day events, all of which have cascading impacts on populations. While these are the most dire of consequences, there are damaging consequences to consider like commercial, financial, and operational damages, impacts to individual, organizational reputation and trust, and regulatory implications like those associated with the GDPR in Europe. In practice, the OS diversity applies at all layers of the OSI model, but in this talk, we primarily address diversity at layer 6, in particular where it implements system resilience and introduces vulnerability, intrusion, and fault tolerance. I cover application and hardware diversity as well, briefly where defense and depth strategies are concerned. So OS diversity serves as an insurance policy ensuring that distributed systems are capable of functioning as intended even under adverse conditions. And these are reasons for considering OS diversity within a distributed system. I should add here that I'm not privy to any case where Verisign has executed upon an OS diverse strategy, but I wouldn't be able to talk about it if I were. I'm also unable to disclose many details regarding Verisign's use case. Zero-day defenses are a key aspect in diverse strategy and can be invoked to limit impact to targeted components in networked and distributed systems. It introduces the capability to offline or realign system components or resources to maintain proper system function. It reduces the window in which systems are vulnerable to 0 days. And more complex defenses are increasingly prudent in an age where AI-powered attacks are increasing in frequency and complexity. OS diversity introduces defense in depth strategies. Defense in depth is the implementation of security strategies at multiple layers and at multiple layers in distributed systems. Consider, for example, that OS diversity primarily deploys different OS kernels. That means that one may be vulnerable to vectors that the other is not, and vice versa. So additionally, such a notion enables the deployment of multiple host-based firewalls, like IPF or PF on the BSDs, and IP tables or NF tables on Linux. All of these provide diversity and defense in depth. The OS diverse strategy also plays a part in direct networking, where FreeBSD ports makes NetMap available. And Linux uses DPTK. As you can see, different OSs provide OS diversity in various different technologies. But that's not all. Diversity may also be implemented with diverse hardware platforms in compute and networking systems, which serve as part of a defense in depth strategy. Increasing depth in defenses is a sound strategy that requires attackers to form increasingly complex offenses to impact system behavior. OS diverse applications enable strategies to reduce single points of failures, like attack surface mitigation, which divides or isolates attack surfaces into smaller, less connected components. Consider an application that deploys small discrete components and functions across platforms like .NET or Java, and that the discrete components are isolated from others. The fragmentation of system components in multiple operating systems limits the ability of a single point of failure having global systematic impact. OS diversity thus improves a system's ability to handle varying workloads in normal and atypical circumstances. And I'll touch a little bit on that in a minute. OS diversity aligns with Verisign's Atlas platform. That platform is our platform, which several of our applications rely on for global DNS resolution in A and J root. Now, there are many more examples where OS diversity is valuable than these that we're going to talk about here, but we don't have the time to discuss all of them, so only a few examples were selected for Linux and FreeBSD to briefly describe. Let's first talk about Linux for now. The XZ utils backdoor is a semi-recent disclosure. Who recalls that? Some of you may, yeah. See, many of you recall that since it was disclosed in the not-so-recent past. It's an example where Linux was impacted and FreeBSD was not. It was discovered in March 2024 by an engineer investigating performance regressions in OpenSSH. And it enjoyed wide deployment. After we investigated it, we concluded that the malactor was the leading XZ development developer, and he committed the vulnerable code to the liblzma library. And it enjoyed wide deployment, particularly with Debian. The malicious code targeted Linux-specific technologies and permitted remote users presenting a specific private key to authenticate and remotely access systems. FreeBSD was not impacted by this because the prerequisite infrastructure like autoconf-generated scripts and make files are stripped when they're imported into FreeBSD. FreeBSD was not impacted because of that. This isn't to dismiss the supply chain risk. The reality is, though, that it targeted Linux-specific technologies that are not implemented in FreeBSD. That is kind of aggravating. There's also dirty cal, which is a race condition in the way that Linux kernel's memory subsystem handles copy-on-write breakage. Copy-on-write is a memory optimization strategy that writes new pages when a process needs to modify the original page. It leaves the original page unmodified, so other processes using it are not impacted by modifications. The race condition is said to have existed in the implementation for about 10 years before it was discovered. Dirty cal allows local privilege escalation with a successfully implemented attack that permitted unauthorized users access to read-only memory used in the copy-on-write technique. There's a use after free flaw in Linux kernel socket implementations, is also an example of Linux-only impact. The nature of the flaw is that the implementation neglects to set a null value for a certain structure member, and it allowed local attackers to run arbitrary code or cause a denial of service in the sockfssatter system call. So with FreeBSD, there's a few examples here as well. The selective ACK infographic here is AI generated, just for those that I know. So there's a TCP recent or selective ACK denial of service that impacted FreeBSD 12. Recent and selective ACK is an optional TCP extension implemented in implementing connection-based TCP services. This is to say that FreeBSD systems are not impacted unless it was compiled in. Selective and recent ACK is particularly useful in environments with high packet loss or reordering behavior. Senders can retransmit packets that seem to have been dropped. A well-crafted TCP recent ACK packet could cause a denial of service in FreeBSD where lists in memory can grow unbounded, ultimately causing a denial of service. Linux's recent or selective ACK implementation differs enough that attackers would need to change the attack vector in order to exploit it. There was recently, in 2018, there was a kernel memory disclosure in get and set context system calls. Those were in FreeBSD 10 and 11 in particular. They presented incomplete initialization of struct padding in the kernel. The system calls provide a userland interface to getting and setting context of calling processes, and they returned incorrectly initialized structs to the user process, exposing small amounts of kernel memory. Unprivileged local user programs may then be able to access this privileged kernel data and exploiting the weakness. Linux kernels were not impacted because the system calls are kernel and OS specific. And now we have Ktrace. Ktrace, this was announced earlier this year, impacting FreeBSD 14. Ktrace kernel memory disclosure. So Ktrace enables the FreeBSD kernel process trace logging for specific processes and logs such traces until the process exits or the trace point is cleared. In some cases, Ktrace will log the contents of the kernel structure to user space. This can result in up to 14 uninitialized bytes of kernel memory being leaked to user space, thus allowing the caller to view the contents of the structure. Because FreeBSD Ktrace is FreeBSD kernel specific, it did not impact Linux. So again, these are only a few examples where many, many more exist. I'm curious if anyone has any examples of other Linux or FreeBSD only vulnerabilities where the other was not impacted. Does anybody have an example they'd like to throw out? You in the back? Yeah, wait for the microphone so that the stream can hear. Can you take that microphone? We got noise in the room.
There was vulnerability in Umutex op, which they used to break Sony PlayStation, I believe.
You're talking about a vulnerability in the Sony PlayStation. Was this the FreeBSD based?
Yeah. So there was a bug in Umutex op kernel primitive, which they used to crack, basically get kind of kernel level privileges on Sony PlayStation, which runs FreeBSD kernel.
Did it only impact the Sony PlayStation?
Yeah.
Yeah.
Obviously, because they use FreeBSD for the kernel.
Okay. Yeah. Does anybody else have an example they'd like to share? No? Okay. Moving on. So I've got to start this slide out. Who uses OS diversity? I got to start this out by stating that organizations understandably tend not to disclose details of their infrastructure, like the use of such strategies. So there's only a couple of confirmed examples. Web searches and AI bots, they like to provide results indicating some organizations use it, but those results must be validated. I came across many examples that I researched that turned up no actual evidence supporting that they use OS diversity. That said, here's a couple of confirmed of such cases, and the subpoints here are going to be direct citations. So the Swiss Post e-voting system, it's an electronic voting system implemented by the Swiss canton of Geneva that allows its voters to participate in elections electronically. It's intended to increase participation, particularly among citizens living outside the borders. Two other electronic voting systems are implemented by other Swiss cantons, but aren't confirmed to deploy OS diversity. The Post e-voting system, they use Debian and OpenBSD. They deploy it for zero-day resilience, further indicating and stating that simultaneous compromise of both kernels is deemed non-credible. So that is why they use a diverse OS strategy. It's relevant to any CVE targeting systems like IP tables or NF tables in Debian versus PF in OpenBSD. And it's consider CVE 2024-42-270, which is a null pointer dereference in IP tables NAT. OpenBSD is not impacted by virtue of implementing PF as opposed to IP tables. And this system is described in the audit report here by Brian Ford. I've got to start this slide out. Again, we say that we can't disclose many of the details of our infrastructure, but Verisign operates two DNS root server operators, two DNS root servers, the DNS resolution platforms, and common net registries. OS diversity is deployed in some capacities in these systems for its zero-day defense capabilities. And as mentioned a minute ago, diversity is important to us in the DNS and ComNet registries. We are focused on enabling secure and resilient communication on the internet, and diversity is a big part of that. It empowers us to manage infrastructure in OS kernel-specific targeted attacks and denial of service events where zero days are prevalent. For example, when Linux is impacted by a zero day, that infrastructure can be offlined or realigned to mitigate those impacts. So if one OS is impacted by a zero day, one side of the infrastructure is unavailable for attack in that case. And these two publications here are articles by our CTO, Bert Kaliski, that talk about how diversity is used. And Sean Michael Kerner also published an article about how open source FreeBSD is used in our infrastructure. So why use FreeBSD? An organization may choose FreeBSD as an alternate OS based on, but not limited to, 3 different criteria: common support, standards focus, and common tooling, and performance and stability. Let's briefly talk about each one of these. Community support. FreeBSD is supported by a large active community of developers. The project is further supported by the FreeBSD Foundation, whose purpose is to support and promote the OS and the community worldwide. There are FreeBSD mailing lists and bug tracking systems that enable and simplify engagement with the community. These allow users to engage with the developers, precluding a need to develop relationships in the community. Consider the case of a FreeBSD bug report Verisign opened early in our adoption of FreeBSD. We had observed panic and freezing conditions in the FreeBSD 8 kernel in the kernel function UDP input. This resulted in page faults that manifested under some high DNS workloads. Our investigation found similar behaviors described on the FreeBSD net mailing list, and it led our investigation to conclude the nature of the behavior was a race condition in several UDP system calls. So armed with this information, we submitted a patch in the bug report that was ultimately merged into the base OS. So FreeBSD's adherence to the POSIX standard and use of Git were cited as factors simplifying our engagement with the community. And another case that demonstrates how easy it is to engage with the community happened while we were testing a particular NIC with hardware OEM. The OEM knew of a FreeBSD committer, Sean Bruno, and connected us with him on a conference call. We described the behavior we were seeing to him, and he immediately was able to identify that a patch had been committed on another branch. So we merged that commit to our branch, and it was tested and successfully addressed the behavior. Unfortunately, I can't recall the details of that condition, but the experience here is what was more important. The FreeBSD community also hosts numerous conferences and local BSD user groups in many cities across the world. The BSD conferences like BSDCan, EuroBSDCon, and AsiaBSDCon are staples in the community. And some other BSDCons have come and gone. Meet BSD and Verisign even hosted a few VBSDCons. We've also plugged into BSD user groups in the Washington, D.C. metro area on several occasions. Be sure to check out freebsd.org for a list of BSD user group near you. The BSD community focuses on standards and common tooling. And these are also factors contributing to our decision. What was that? So these were factors that we considered while we were looking into and deploying FreeBSD in our infrastructure. Adherence, like I said a moment ago, adherence to standards, notably to POSIX family of standards, factored into that decision to use FreeBSD as an alternate OS. POSIX is important in the context of OS diversity because implementing code in accordance with the standard reduces the time and effort necessary to manage custom code and on multiple platforms. Many applications are already implemented according to POSIX and already support making cross-platform implementations stable, portable, cost-effective, and simpler to deploy. And additionally, many developers in the community were and continue to be familiar with Git, and since we are already familiar with it, it also factored in. These factors enable implementations to be upstreamed into the BSD OS, relieving users of the necessity to support custom code. A couple of the problems associated with custom code include managing such code and refactoring it and integrating it for each release of an OS. This all adds time and effort to a process that isn't necessarily focused on an organization's core mission. Performance and stability of the FreeBSD OS are also contributing factors considered in a diverse OS strategy. In terms of stability, FreeBSD adheres to a rigid API compatibility approach, so kernel interfaces aren't changed or deprecated as drastically or as often as can be the case with Linux. Consider the case of Linux's migration to systemd, thus deprecating System 5 in it. Significant effort was required by many users to migrate their applications to the systemd framework. The RC framework in FreeBSD is stable and doesn't deprecate an application's service management script. This is to say, within a major version of the OS, APIs will be compatible. For example, getContext implements the same API in FreeBSD 13.0 as is implemented in 13.5. And it's only the major versions where such changes are implemented if appropriate and necessary. FreeBSD's minimalist approach to OS installations supports stability by installing a minimal set of applications as well. This reduces the available attack surface in BSD compared to Linux. And FreeBSD's networking performance was also very much on par with the Linux alternate choices. So, in conclusion, OS diversity plays an important role in securing systems. There are many reasons and use cases for implementing it, and there are a plethora of factors to consider when selecting an alternate OS in a diversity strategy. This is not intended to be an exhaustive list of factors to consider, but they are all reasons an organization may choose FreeBSD. Verisign considered many of these factors in 2010 when we selected FreeBSD as the default, as our diverse OS platform. None of this is to imply that the other major BSDs are insufficient. They are all solid choices as well. And with that, I'm able to open it up to questions and answers, if there are any. We got one here.
So you said that you presumably considered NetBSD and OpenBSD, and I'm just curious if you can sort of illuminate on why you chose FreeBSD out of the BSDs.
We're a little far removed from that now. Like I said, we've been using FreeBSD for 15 years. So I can only speculate at this point, but I do remember doing a review of vulnerabilities and security advisories and errata notices between the BSDs, and we found that FreeBSD had fewer relative to a lot of the other alternate systems. We also found that FreeBSD had the larger community out of the major BSD OSs. In fact, they were supported by the FreeBSD Foundation, which obviously has a pretty good pocket of that they're able to use in support of the community itself. We wanted an OS that was backed up by an organization that was able to fund projects and things like that. Anything else? Ed?
I think the diversity story is a really good one. I think probably one of the common arguments against it that folks might have is that it can be very expensive to sort of duplicate your stack and infrastructure twice. And so, do you have any thoughts or comments on how you would respond to organizations that have that concern?
How important is your infrastructure? Where does it fit? What does your infrastructure support your business? And what kind of impact are you willing, or what kind of effects and impacts are you willing to accept? We run DNS, and for us, it's a no-brainer. We enable the internet to securely and reliably run, and the cost in that regard is, we factor that in. Okay, if there's nothing else, I'm finished. Thank you very much.